Hi guys, Arpon Mukherjee here, coming back with a brand new chemistry episode. Yes, it's been a long time since I have appeared here. It's been 1 month. It is that I decided to quit this channel, but some of my friends said to me uh, they want it again, so I have decided to come back. And today I will talk about Perkein reaction. I was searching YouTube about this reaction, and I found many of the YouTubers not doing it properly. They are just skipping steps, and they are not proper. So I will show you today the mechanism, detail about the reaction, so we can get started. Okay, the Perkein reaction is where the aldehyde such as benzaldehyde, aromatic aldehyde is taken. Okay, aromatic aldehyde is taken such as benzaldehyde. It is benzaldehyde, and it is a substrate, and it reacts with an anhydride such as it is acetic acid and acidic anhydride. Okay, and in the medium of salt of acetic acid, sodium salt of acetic acid or potassium salt of acetic acid. You just need a salt of the corresponding acid of the anhydride. Okay, and the product is it is a alpha beta unsaturated acid. It is called cinnamic acid. Okay, so Perkein reaction is used to prepare cinnamic acids with benzaldehyde or aromatic aldehydes and the anhydride and the corresponding salt of the acids. Okay, and now it was invented by Sir William Henry Perkein, a British scientist. Okay, now I will show you the mechanism now. Okay, it is not that this reaction is very important for the plus 2 level students. This reaction isn't that much important, but for knowledge, I saw many of the YouTubers doing it wrong. I am just doing it. Alright guys, now the mechanism. Step 1, you can see first the acetate ion reacts with the anhydride. Okay, it abstracts a hydrogen, then it forms this side product. We don't need it. Okay, now then step 2, the benzaldehyde or the aromatic aldehyde to say is attacked by the carbon ion. This carbon ion is pretty much stable. Why? Because it had a resonance. I can see here. So it is pretty much stable. Now then this one. Okay, this attacks here, and then this. See guys, oxide is formed here. See, so it is pretty. If this minus this anode is pretty much, this charge is pretty much localized, so it is not very stable. So what it does that it makes a shifting of charge. It shifts the charge. Okay. Now for the information, I have seen the many YouTubers what they do from this step, that they use acid ion here. See, I am doing it here, but it is not right. I am doing it, but still it is not right. Okay. They abstract a proton from here, and then they are showing it like this. OH single bond, CH2, C, OCU, CH3, and then what are doing? that they are showing that the here the hydrogen atom, they are showing that the acetate ion abstracting this one and OH is living like this. But I, for your information, that OH isn't a good living group, and it doesn't live like this. Okay, and this acid ion is in that strong ion that it can remove hydroxide ion. So this step isn't possible. Sorry, this step isn't possible. This step is not possible. But they are doing it. The YouTubers doing it, and then they're forming this, and then they are hydrolyzing it. Okay, hydrolyzing is possible. It is not the case. And then they're forming the cinnamic acid. This is the thing they are doing, but to be precise, this is the wrong thing. This is wrong. It is not right. Okay, so what is the right step? So the step 3. So where I was here, this compound was formed, this intermediate was formed. See, and see the charge here is localized. The charge, minus charge in the oxygen atom is localized. So the charge will shift. I am just drawing it another way that you can understand a 6-member ring will form. So I am drawing it in another way. Okay, just see it, that you can understand what is happening. Minus here. Okay, CH2 C double bond O here, C double bond O, and here is CH3. Okay, I'm just drawing it like this that you can understand. And then the minus ion attacks here, the double bond has shifts here. Okay, the pi bond shifts there, and then then the compound look like, the intermediate look like this one. Okay, so this is the intermediate, you can see. Then what is happened, I told you earlier that the negative charge shifts in a stable manner. Okay, so it comes back here, and then we get the intermediate like this, CH2 C, and this one totally CH C double bond O CH3. Okay, this is the intermediate we got. It is a living group, you can see, but it is not living as yet. Okay, the step 4 comes to place now. What is step 4? This intermediate again attacks another anhydride atom. Okay, this one. So this intermediate again attacks a anhydride atom here. It goes back, and then this one. You can understand. Now the intermediate was formed is like this one, OCOCH3 CH2 C double bond O C double bond O CH3. Okay, you got this one. Now step 5, you can see it's a very big mechanism, and the YouTubers are cutting it up. So then next up, we get the acetate ion back. Okay, this acetate group CHH this acetate group attacks here. Okay, attacks this carbon atom. See, this is the base. It goes back here. It is a good living group. It lives. Okay, then the double bond forms. And then the step 6, the next step. So step 6, you have the compound now like this. The intermediate is like this CH double bond CH, C double bond O CH3. Here pretty much hydrolysis happens. Okay, H3 plus acid and water. Here what happens? This one cuts, and then we got the cinnamic acid, and the acetic acid. Okay, and this is our product. We needed this one, cinnamic acid. So by these steps we produce the cinnamic acid. And now see the what were the YouTubers doing. See, they were what doing? They were just they were acting this like a base, and then they were OH was leaving. But OH isn't a good leaving base. OH minus is stronger base than CH3 double O minus. So OH minus can't get into the medium. So this is not possible. Okay. So you see the steps how can we prepare cinnamic acid. And now see the yield of this reaction is not pretty good, but it's still 56 to 60%. It's pretty much average. It's average. We get the average yield of the product, and the rest of the side products mean cumin. How we get the cumin product? You can see in a step that we can see. Okay, see, this was one of the intermediates. Okay, in one of these intermediates, when this compound wasn't formed, this intermediate wasn't formed, just the intermediate was like this one. Okay, cutting it off. Okay, just what happens that it leaves like carbon dioxide. Okay, when you see it was our intermediate was like this intermediate. Okay, when the minus of the oxygen here forms double bond here, and the carbon dioxide leaves. Okay, so then our intermediate formed like this. Okay, and then the minus stop here, and then this leaving group leaves. Okay, then so the side product is cumin. Okay, so it can happen. Is the side product is the cumin. 20% of the media, 20% of the product is cumin. So by this mechanism we can see that formation of cumin can happen, and the product cinnamic acid also forms 55 to 60%. Okay, so guys, thanks for watching today. That's all for today. Subscribe to my channel and like this video if you like my effort. And please guys, you have something to do for me. I want to do a video where I show many problems that I can feature in my channel, and I want you guys to send me problems so that I can feature them in my video. I want to do a video that can help you guys to solve problems. I know you guys are giving +2 level exams, so I want you to send me questions. I will solve those for you guys. Thanks for watching. Be safe.